Find the nature of the stationary points on the curve y is equal to 4x cubed minus 3x squared minus 6x plus 2. So we've got y is equal to 4x cubed minus 3x squared minus 6x plus 2. So first of all, find the first derivative. So to differentiate a curve, if y is equal to ax to the n, then dy by dx will be anx to the n minus 1. So differentiating term by term, so it becomes 3 times 4, which becomes 12x squared, 2 times 3, which becomes 6x. Differential minus 6x will become minus 6, and when you differentiate a constant, you get 0. There's a common factor of 6 here, so we'll take that out, and then we'll factorize the middle. This is a quadratic, it's quite an easy one to factorize. It factorizes down to 2x plus 1, x minus 1. If you can't do that, then maybe I suggest you use the sum product factors method. Therefore, we have to put, next thing, to find the stationary points, we have to find where this is equal to 0, because therefore we have a horizontal gradient. Therefore, putting dy by dx equal to 0, we put this function equal to 0. 6 cannot be equal to 0, so therefore either 2x plus 1 is equal to 0, and therefore x is equal to minus a half, or x minus 1 is equal to 0, and therefore x is equal to 1. Therefore we test the nature. This is called the first derivative test. So what we do, we make a table. We look at the particular first value, which is x is equal to half. We look just before and just after, looking at the gradient. So, and remembering that dy by dx is 6, 2x plus 1, x minus 1. All we're interested in is what the sign of dy by dx would be. We know at the particular point the gradient is equal to 0, therefore we get a horizontal curve. When x is just less than a half, let's take minus 3/4 and we substitute it into here. We're going to get a negative. This is going to become, the bracket will be negative because it would be minus 6 over 4 plus 1, which is negative. And then we're going to get minus 3 over 4 minus 1, which is also negative. A negative times a negative gives me a positive. And then just after, we'll take minus 1/4. If we put minus 1/4 into here, it's going to end up being positive. But if we put minus 1/4 in here, it will be negative. We get a positive times a negative, which is negative. And therefore here, this is positive, this is negative, so we've got positive, 0, negative, therefore x is equal to a half, minus a half is a maximum point. Then we do the same for the other point. So make a table, and we know at the particular point it is 0, and therefore we get a horizontal line. Just before, we're just going to take minus 0.5. Putting 0.5 in here, it makes it positive, but 0.5 in here, it will be negative. A positive times a negative will make a negative. Greater than 1, and you should make sure you don't stray too far away from the actual point. We get 1.5, so 2 times 1.5 plus 1 is positive, and 1.5 minus 1 is also positive. Positive times a positive is positive, so here we have negative, negative, horizontal, positive, that looks like a minimum point. Alright, find the y coordinate. So make sure you actually use y for this, not dy by dx, which is quite a common mistake, and then substitute in the values. So we've got 4 times minus a half cubed minus 3 times minus a half squared, 6 times minus a half plus 2. We're going to do it without a calculator. This becomes minus 4 over 8. This becomes, if you square a minus, it becomes positive. We've still got the minus 3, so we get minus 3 over 4. Minus times a minus makes plus 6 over 2 plus 2. So we're going to have minus a half minus 3/4. Simplifying, plus 3 plus 2. If we simplify, which gives me minus 5 over 4 plus 5, which gives me 15 over 4. When x is equal to 1, it's a little bit easier. Putting 1 into y, we get 4 times 1 cubed minus 3 times 1 squared minus 6 times 1 plus 2. So we get 4, take away 3, take away 6 plus 2. We get 3. And then we make our conclusion that the maximum occurred at minus 1/2 15/4 and the minimum was at 1/3. Okay, so that's how to do it without a calculator or a graphing tool. And of course, this is what the sketch of the graph looks like. Okay, so here's our curve. Here's the maximum at minus 0.5 15/4, and here's the minimum at 1/3.